Hello world and welcome back. In Kotlin, there is a specific set of keywords called operators that get translated to an expression. Today we will see one example of how this can be useful to us, and I picked my favorite, the invoke operator. Let's see something. Let's say we have a method that does something, and this gets an argument that is also a method that returns unit. So this is a higher order function, as we say. Obviously, inside the do something method, we can access the arg function and we can call it, right? Yes. Now, behind the scenes, this is simplifying .invoke. So basically, the invoke keyword is an operator that gets translated to a method call. So that's why we can omit it. Now, with that knowledge, let's see how this can be useful to us. One of my favorite ways to use this is in a use case. Now, as we've talked about in previous videos about clean architecture, a use case should do one thing only. That's why we can call it atomic. So let's say that here we have our first class, first use case, that is obviously doing one thing. And usually we call it execute or something like that. And inside it, we perform some sort of business logic. Now, on our other files, when you use it, let's say we have a first use case. This is the object that we're creating, and we can call the use case like so. And this works very well. And let's say we have another use case that's the second use case that does something else, again, an execute function inside. And of course, going back to our other file, second use case. All right, in the same manner, we can totally call the second use case. And this works okay, but as you can see, since it's doing only one thing, would it be better to avoid writing the execute word all the time? Well, as we've seen before, the invoke operator can work in this case in our favor. So if we rename this to invoke, and we add the operator fun keyword before the invoke method, what we basically did is we overloaded the operator. So we took the keyword in Kotlin that is reserved for a method call, and now we can do whatever we want. In the same manner, we will do it in the second use case, also call it operator fun invoke. Of course, execute doesn't work now, but if we name it invoke, it works. And the best part now is, as we've seen in the first example with a higher order function, we can totally avoid writing the invoke and it still works. One bonus thing here. What I like to do in my projects, since this is a use case and only does one thing, as you can see, this would be much better off being an interface. So what I like to create is an interface called base use case. Depending what you want, this can also be an abstract class. And this has an operator fun invoke method. Now, those use cases will implement the base use case, and the same will happen here. In the first use case, we can add the override modifier, and that works perfectly. So, one more thing I'd like to show you is this most of the time we're using coroutines, this invoke method can be a suspend function. There's no problem in that, just add a suspend in front of the operator fun, also making this suspend, and it works perfectly. So all I have to do now is make the main a suspend fun and delegate to whoever will call this main to put it in the proper coroutine context. Thank you very much for watching, and I'll see you in the next one.